Colton, can you hear us? Just a second while we get Colton on the line here. Sorry about that. Colton, are you there?
Yes, I am.
Okay, here we go. Sorry about that, folks. Colton, go ahead and take it away.
Okay. Well, like Jacob said, we are showing in X1.4 today. This will be our next upcoming release of SigmaNEST, hopefully in the next few weeks here. It's in final testing right now, but we are going to show off some new features in that, as well as new features since X1 has been released. So we're going to jump right in. Probably the biggest thing to know is that SigmaNEST is now a 64-bit program. That will give SigmaNEST more access to computer resources such as memory. You should be able to save and open larger workspace files, work with more complicated parts more easily, and see an improvement in the nesting as SigmaNEST is able to take a large number of parts and rotate them in very complicated ways, very fine degrees of rotation, and get very good results with our nesting. Now you should all be able to see SigmaNEST X1.4 on my screen here, and I'm going to start working from the user interface stand. Nothing new here really as far as looks, but one thing we have added is the ability to customize all of your toolbars. So I'm going to add in our DWG importing into this custom toolbar I've made to get all of my most common files imported rather than having to go through a drop-down list. So I just find my command on the left-hand side, add it into the group that I want, and I'm going to reorder that up next to DXF importing. And then I'm just going to rename this to my importing section. And under my files, I'm going to remove the import dropdown. So now I have all of my most common import commands set up and ready to go. And we're going to jump in with a DXF import. And we're going to go to our interactive mapping screen. We're going to talk about a few features in here first. Most notable is viewing the different layers and levels as geometry rather than just the names of the layers or levels. In here we'll be able to see the different contours of the part, toggle information or geometry on and off, as well as changing the hole sizes in the geometry on the fly, not having to change the original DXF, just make these changes to round holes on our part within SigmaNEST. We're going to import that. Any geometry changes that we make apply to the part that we import. And now that part is in our workspace, ready to be added into a nest. Another feature we've added is automatic geometry repair. Now there's a lot to the geometry repair options that we have, and I'm just going to show a few of them here. The first is trimming off an arc to end or an arc to line intersection. Rather than having to open this up in another CAD package and repair the geometry, SigmaNEST will do that for us automatically. It's going to tell us the type of repairs that were made, and we have our updated geometry to create this as a valid part. We're going to go back to our part list here. We have another line to arc intersection that gets automatically repaired. And then finally we have line to line intersections on a multi-part drawing. All of these are going to be repaired, and we'll be able to get 3 correctly drawn parts in SigmaNEST. And like I said, there are multiple options or more options that I don't have the chance to show this afternoon, but I do want to show you the capabilities that are offered for the geometry repair. We already looked at the line-to-line intersection that gets repaired, the line-to-arc intersection that gets repaired. We have arc-to-arc intersection that can be repaired from overhanging edges on your arcs and clean that up, as well as merging arcs to be continuous rather than having multiple pieces. This can simplify your geometry. And then the last would be an overhanging tangent edge. That little bit is going to get removed and be left with a smooth transition into your contour. Now, while I'm in here, I do want to take a moment to point out our new help file. It's been updated since the old style of Windows help files and is now an HTML compatible help file. This has a lot of advantages for editing our help files, making sure they're up to date, having pictures here that can be dynamically sized and viewed. All of the search capability is right at the top. Enter in a search and it's going to return every page of information that you would ever need. Now, along with that, we do support Google Translate, so if anybody is viewing from out of the country, you can change into any supported language under Google Translate. Now, jumping back into our interactive mapping import, all of our geometry has been repaired and we're ready to import these parts. And I will end up with 3 distinct parts. Of course, if I would have had my multiple part options turned on when I created these parts, these would be 3 distinct SigmaNEST parts, not the one that we see here. That's just an import option that we've always had, not related to any of the geometry repair that we just talked about. Now, with new versions of SigmaNEST, we do support PDM systems. We support Siemens Teamcenter, PTC Windchill, SolidWorks PDM, and Autodesk Vault. All of that can be set up and configured for your installations of SigmaNEST if you require it. So that covers some of the importing options. With existing parts, we've made a lot of improvements to our parts list. Right now I'm sitting on, or rather in the folder of my parts. You can see I have 704 parts in this folder. I have a number of subfolders under that. When we're browsing a list of parts, we can include subfolder parts. We don't have to go into the individual folders and find the parts that we want. They can all be found in this list. Now, in addition to that, if you have parts across multiple folders that aren't in a subfolder, perhaps, you can now load parts into a load queue simply by selecting the desired parts, hitting load, and this will load it into a queue to be loaded. It does not close your parts list. At this point, I can go to a completely different parts folder, and if there are parts in that folder, I would be able to select them here, and I can jump back around to multiple locations, load parts, and they all get loaded into this queue so that I can quickly load sets of parts into my workspace. And there I just added in 16 more parts. All right, so next we're going to talk about our nesting. We have 4 new nesting types. First is HD True Shape. This is an improvement on the True Shape nesting modules. It is very fast, very good at finding optimal layouts, and is one of our faster and newer nesting engines. This is definitely one of the improvements with the 64-bit application. I'm going to re-nest this here, and this should only take a few seconds to get about 160 parts laid out on 2 different sheets here. And we can see the result of my nest Obviously, I can set my time to run longer. I can allow this nest to go further. HD TrueShape will free rotate parts that are set to no grain to allow the parts to really rotate and get the best yield out of a given size of material. Now, the next I want to talk about is an improvement to our rectangular nesting engine. I've got about 100 parts here across 3 sheets, and we're going to take a look at my last layout here. This is our base rectangular nesting engine, and if we look at the bottom left of SigmaNEST, it's using up 106 inches of this plate. We're releasing a new nesting engine called HD Rectangular. This will offer improvement in both the speed that rectangular nesting works and the overall yield. So again, we're looking at our last layout here, and we're using 83 inches. So just changing updating some of our nesting engines to run faster and to use less material, which is always a good thing. Next is our next engine is called HD Multi-Drop, and this is going to be similar to rectangular nesting. It's designed for rectangular parts that are coming off of automatic plate processors such as the Wortmann cutting machines. You'll see a lot of common edges that are aligned here, and the goal with that is to process these as a column, and then the machine has a part door that drops out and the parts get unloaded. The machine cuts off the scrap, and then it processes this next column of parts, and it continues pushing the sheet, processing from left to right. Now our last nesting engine we're going to talk about here is called HD SuperNEST. This is a time-based nesting engine and has full ability to rotate parts by 1-degree increments as long as they're set to a no-grain part. And this nesting engine really does a great job. This is our best nesting engine that we have. We're going to take a look at 2 sets of parts. The first is a baseline layout. Our goal is to nest as many of this oddly shaped part on this sheet. The next 3 nests that we look at are going to have the same part, same sheet size, and the same edge and part clearances. So we're running on the same playing field for these nesting engines. So here's kind of a baseline nest. We've got 548 parts on this 40-inch by 50-inch sheet. Next, we're going to look at the HD TrueShape result. HD TrueShape is the first nesting engine that we looked at. This was able to get 772 parts onto this sheet. And then HD SuperNEST is able to get 784 onto this sheet. And it does that by rotating your parts, getting them nested as closely as possible, and nesting groups of parts. And you get a very full, well-used sheet from a very odd-shaped part. Now, what HD SuperNEST does is you set up a time limit for it to run, let's say 60 seconds. During that time, it sets up a baseline nest, and from that moment, it has 60 seconds to find a better yield. As soon as it finds a better yield, the timer resets, and it has another 60 seconds to find the best yield, or a better yield. And that process continues until the nesting engine runs out of time and it can't find a better yield over its previous results in that 60 seconds. We have options to control that up to nest for up to an hour in those time increments. So it will have 1 hour to find an improvement. When it does find an improved yield, the timer resets and it goes for another hour. So if you have very high value materials, this is a very good nesting engine to get every square inch out of your material as possible. So we're going to take a look at another HD SuperNEST example. Again, another ring, Slightly different shape, but just as complicated to go through and nest. And on my baseline, I have 375 parts nested. For HD True Shape, I have 413. And for HD SuperNest, we're able to get 3 more parts on there for a total of 416 parts. Again, this is the same part across all 3 nests, the same sheet size, and the same clearances. The only thing that we're changing is the nesting engine that's putting these parts on the nest. All right, we're going to move on to some new features for our toolpaths. I'm going to start out with punching. Go ahead and clear my NC from this. Now I went ahead and created this odd-shaped part. I'm going to show you what we call tool patterns. Now I have a specific way that I want to tool this little recess here. I want to have a large square punch this out, a smaller square punch down into that nook, and then a round nibble out the arc here. And I could go through and I can manually tool that. But I want that to apply to every instance of this part, and even if it shows up on other parts that have the same feature but are a different part themselves, I want that same tooling to be applied. And so to do that, we use a tool pattern. And a tool pattern is simply a shape that we want to apply a series of hits to specific geometry. And I'm showing you this with manual tooling, but auto tool will also pick this up and match the geometry no matter where this geometry occurs, if it's on the same part or a different part. The idea is we have a specific set of tools that we want for this feature, and we want auto tool to always use that. So when I go through and I hit auto tool, I'm going to zoom in here, and you'll see the same tool pattern that I just used. The large square at the top until we get down close to the arc edge, a small square nibbling down into the corner, and then a round nibbling out the arc. And that gets applied to every instance, and if the tools are symmetrical and can be rotated, to every orientation of that geometry. This is very good for parts with families of features that show up across multiple parts, but the parts themselves are fundamentally different, such as different lengths or slightly different sizes. This allows you to put up very fine control over the tooling while still being able to leverage and take advantage of the auto tooling capabilities. Now the next part I want to take a look at is over here. We're going to take a look at this cross-shaped part. We understand that with punching there's always a need for manual tooling. However, we do want to automate as much as we can. So we have an auto single hit option. With that, you can select the type of contour that you pick, you can filter down the types of tools that are used, and then you go through and you select the geometry that you want to tool automatically. Right click, and if it goes through and finds a compatible tool, it automatically places a single hit. And then after that, I can come back and I can manually tool just like normal, and I can start nibbling out my exterior or my external profile if I want to manually tool this part. Both the tool pattern feature and the auto single punch is available in part mode so that you can pre-tool parts. I'm simply showing you this on the nest. All right, I'm going to move on to some profile improvements. First thing that I want to show is what we call curvy rapids. Rather than go in a straight line from hole to hole, which can place a lot of wear and tear on the servos and the rack and pinions on your machines, we're going to put an arc into those movements so that we can slow down and ramp into the contour rather than just simply speeding up and slowing down. This is something that has to be compatible on the machine, and it's simply set up in your post processor. If you have any questions about that, please contact our support team. We'd be happy to talk to you about enabling that in your post, assuming that it's compatible with your machine. Now, for those of you who use center of gravity tabbing, again, just a quick reminder, center of gravity tabbing looks at how the part is nested and where the part falls on the machine slats. So on my screen, you should be able to see an outline of my machine bed. The orange points represent the peaks of my bed slats. And center of gravity tabbing has been improved to not only work with straight slats just across the bed, but also with angled slats, curved slats, and point clouds or peak slats like this. All that gets set up in the DXF and the post. Again, if you have any questions to getting that set up, please call our support team and we can help you get that set up here. So we're going to zoom in on some of my parts here. First, this big part does not have any tab on it because it's resting firmly on multiple points. It is not a tip hazard. However, we have this part here which rests on only 2 points. That one is going to get our lead out tab placed on it. And same with this part here. We're resting on only 2 points of the slats, and so we're going to put a tab to make sure that our part doesn't fall through and get lost. The other thing I want to point out here is NC fillets. We've added a lot of control over where the fillets can go. I'm going to take a quick look at that here. We've added filters for internal and external contours, as well as the type of corner, whether it is concave or convex. And so as we go through my nest, you can see that on my convex corners, I have a fillet applied, but on my concave external corners, there is no fillet. Similarly, on my internals, fillets are never applied because I've turned that off. So some improvements there for helping you guys use SigmaNEST to the best of its abilities, to run your machines to the best of their abilities. Yeah, hopefully that gives you an idea of some of the new features there. I think, Jacob, was there anything else specifically that you'd like me to point out or show?
I think you did a very good job here showing most of our new features. Nothing that I can think of.
Okay. I think we can put up the handout there for the what's new. Like Jacob said at the beginning, I wanted to go through and highlight a lot of the key new features, but I understand that there are a lot, and so we're going to provide a compiled PDF of all the what's new guides since version 9 has been released. That way you can go through and review any new features that have been added. Some of them have videos or descriptions showing what to do or how to use them. If you have any questions about it, feel free to contact our support team. We're happy to answer questions, to show you how to use features, and we're here to help you guys with your manufacturing and your use of SigmaNEST.
Yeah, in the handout, just so everybody knows, the handout, just expand that section in the control panel, and the GoToWebinar control panel should be under handouts, and you'll see it there, and you can be able to download it right there. It looks like we have a question, Colton. Do you see the question there?
I cannot. I don't think I can see the chat right now.
Oh, okay. Well, in the question it says, in nesting feature, can we sort out small parts from the big parts? That is, if we want all the small parts in, I guess, one corner of the sheet. I guess that's what he's asking.
Yes. Yes, we can do that. So let me jump to a new task here. in our nesting, we've added options to sort out our parts based on a number of features such as area, perimeter. Those have always been there. We have added small parts first, and then we have to pick a secondary sort order for the non-small parts. So these would be parts that are designated as small parts in the grain tab of your part parameters, or any parts that fall under the small part dimension in task parameters. And so then these parts would get nested at the very beginning of the nest, and then once all of those parts are nested, the secondary sort or part order takes over, and it would start sorting, in this case, based on the gross area, the size of the external contour.
It looks like we have another question from Brad. Common line cutting. Is there common line cutting for lasered parts?
Absolutely. Yes, we have a number of common line nesting as well as common line cutting options. And I'm just pulling up my help file because I know I have some pictures in here. So we have multiple options for common cut nesting, like I said. And so our first, we do pairs of parts as well as large groups of parts. Those would be the nesting options. And then our cutting options range from cutting in a pair of parts, cut 1, 2, 3, 4, and rapid to cut 5, 6, and 7. And we get our 2 parts out. We have a figure 8 style cut where we rapid to the middle of the nested part, cut the sides of 3 sides of one part, cut across the common line, and then cut the remaining edges the opposite direction. We have a laser specific option where we cut the common line first, and then we cut the large external altogether. And then if we're doing a multi-part nest with common line, we have an option to go through and cut all of the common edges first in every direction, and then we go back and we cut the large outside perimeter.
All right, looks like we got another question from Tim. Can the same parts be grouped together when nesting by part name? And he says sometimes we have hundreds of parts that look similar, so we try to nest them by part to identify them better when uploading the parts.
Okay, there's a number of ways we can do that. One is through pre-nesting. When you set up a task, you can hit this pre-nest button at the bottom of your parts list, and that brings up the list of parts that you've added, and you can manually nest those together. They have bump options so that you don't overlap parts, and then we can align the bottom edges to give us a group. And now this group of parts can be nested together. The other options that we have with that would be to put the name of the part as auto text onto the part surface. So you can either mark that or put it as just a detail. The detail would show up in SigmaNEST only. We would not see it on the finished part. We would only see it on SigmaNEST and in the reports. And we can choose where to place that. And when I nest that part, we can see exactly the name of that part. And then in our report, we would also get a nest ID in the list of parts and I can we could print the nest ID on the layout of the report, and it would show up on my list of parts down here. So I think my report here isn't configured to show my list of parts here. So there's multiple options for grouping parts, or also simply identifying the parts on the nest as you're working.
Okay, it looks like we have a couple more questions coming in here. We have another question about small parts. When entering in small parts, under small part dimensions, the value entered is a square value. That is, if I enter 2, does that mean 2 by 2? Does that make sense, Colton?
Yes.
Okay.
So this is a length. Both the length and width of the part have to fall under the small part dimension for it to be automatically considered as a small part. So if I have 3 in here and I have a part that is 4 inches long and 2 inches wide, that will not be a small part. If I have a 2.5 by 2.5 inch square, that would be a small part.
Okay. Next question is from Barry. I missed the part where you can go and modify the toolbar.
Okay.
Yeah, I guess just go over that again.
Sure. Simply right-click on in any tab on any button and select More Commands. This will give you the list of all the commands in SigmaNEST on the left-hand side. You'll have the selection for a ribbon tab, the different tab groups. The names here correspond to the names of the different sections in that tab. And then you have the order of the buttons as they appear. To add buttons in, simply select the group that you want to add or remove options to or from. We'll add in something to the Edit NC option, and we'll add in a clear NC. I'm going to add that, and you can see my clear NC or clear detail here on my Edit NC. There are 5 customizable toolbar sections. That's what I worked with on the Workspace tab to create my importing section. Those can be right-clicked on and renamed to suit whatever group of functions you would like.
Okay. One more question. And Barry says thank you.
You're welcome.
Justin asks, on a multi-sheet setup, and I don't know if you have a setup like that.
I can get one fairly quickly.
Okay. On a multi-sheet setup, is there any way to center the parts on the sheet through AutoNest?
So I want to make sure I got the multi-sheets correct here. I may need. Give me just a moment to get this set up. Is this the type of multi-sheet that you're talking about?
Let's see if he answers. Yes, he says yes.
Okay, and you would like the parts to nest along this center line?
He looks like he says no, not in the center, just in the center of each sheet. Did you get that, Colton?
Yeah,
Okay.
like centered vertically or along one edge.
I think he means the center as in just right in the middle of each sheet. Yeah, kind of right there.
Right in here.
Yeah, he says correct.
Okay. Currently, no. The nesting engines are set to work based on the nest reference, which is one of the four corners of the sheet or based on the machine origin, and then it's based on the direction that you want to fill the sheet. This is your strategy and task parameters. Strategy 1 is going to fill the sheet vertically and fill left to right if the origin is in the bottom. Strategy 5 would nest along the bottom and fill top to bottom. And the corner that it selects to base off of is the nest reference here. So for example, if I have my top right nest reference and a strategy of 1, I'm going to start placing my first part in the top right corner and start placing parts down the right edge of the sheet, and then go back to the top and fill down and continue filling the sheet this way. So to answer the question, there would not be a way to start automatically nesting in the center of the sheet.
All right, I think that Tim says he can put in a large edge space to keep the parts towards the center, which is true.
Yes. Yeah,
Yes.
we could put in, we have different edge distances for top, bottom, left, and right. So we could put in, let's say, an 8-inch clearance. All of my parts would be forced to stay towards the center and at least 8 inches away from the edges of the part, or the sheet, rather.
Yeah, so Justin, that might be a good workaround for you in the meantime. I'm not sure. But you would get it towards the middle of the sheet in that kind of way. Hopefully that answers or gives you a good solution there. We have another question from Curtis. This is probably going to be our last question. Scroll back up here. In multi-sheet, is there an option to input sheets in a vertical and horizontal directions at the same time? Essentially a grid of sheets on a cutting bed.
Currently, no. It's either horizontal or vertical.
Yeah, and Justin, just to iterate, just to his point, he says he has material that's thicker towards the middle of the sheet, which is why he would want to nest in the middle, just in case anybody else was wondering. If there's any other questions, feel free to email me directly. My email address should be on the invite, so you can just email me. We can get those questions answered. I answered some questions privately, and I'll get back with you on some of those. But I'd like to thank Colton for going through some of the new features, and make sure you get that handout that we sent. It's under the handouts drop-down. It's the What's New compilation, and that goes from the 9.0 features all the way to X1.3. And yeah, take a look at that. If you're off maintenance or anything like that, and you see, you might benefit from some of these features, I know we'd be happy to get you back on maintenance to get you working with those new features and help you guys get some money there with the automation side of things. So hope everyone had a good holiday, and hope everyone has a Merry Christmas in December, and thanks for joining us. Have a good day.